So marked by good old N, that looks like an M, Mr. Dueck. You need to separate the N's out so it's easier to read. Answer key. Number one, it wants the current and direction through the 5 ohm resistor. Here's what Kirchhoff's current law says. At any junction, there's a junction, current in has to equal current out. I noticed when I looked at this that the current out is 0.75 plus 0.53. I went to my calculator and I went 0.75 plus 0.53. I said 0.75 plus 0.53, and I said the current out is 1.28 amps. You know what the current in has to be then? Same answer. What's flowing in? Well, flowing in, I have 0.96 amps flowing in, plus mystery current I. How would I get the I by itself? Minus 0.96. So first of all, the direction has to be either, you could say into the junction, or you could say down and right. And the magnitude has to be 0.32 amps. 1 mark for each of those. So I saw people trying all sorts of stuff. No. Kirchhoff's current law, really simple. Current into any junction has to equal current out of any junction. I know the current out, I know the current in. 4 resistors and the 15-volt power supply are arranged to show the circuit below. What's the total resistance? Okay, first thing I'm going to do is I'm going to combine these two. These two are in parallel. So the very first thing that I would do is I would go 1 over R parallel, and that's going to be 1 over 10 plus 1 over 10. I think it's going to be 5. 10 reciprocal plus 10 reciprocal, and then the reciprocal of that. Don't forget, go to take the reciprocal of that. Yeah, our parallel is 5 ohms. So now our total is going to be, so these two can get replaced with a single resistor 5 ohms big. Mathematically, it would be like this circuit wasn't even part of it, and this was 5 ohms. Why is that nice? Because now Ella, the 20, the 5, and the 20 are all in series. How do I combine resistors that are in series? Easy peasy. Just do what? Yeah, so our total is going to be 20 plus 5 plus 20. It's going to be 45 ohms. If you got that, I would give you 3 out of 3. Otherwise, if you got that wrong, if I saw that 5 ohms, that would get you 1 mark. If I saw that you tried to add them in series, that would get you 1 mark, and then 1 mark for the answer. What's the total current leaving the battery? Well, I total is going to be V total over R total. V total is, among other things, it's going to be the chairlift battery, which they gave me in this case, 15 divided by 45, it's going to be 0.333333, and that's amps, 0.3 repeating. Pause for a second. Try avoiding rounding off. So I would probably go 15 divided by 45. I would probably store that on my calculator. Then it wants the voltage drop V1 across R1. Okay, so first of all, I know I total, it's 0.3333 amps. Oh, how many amps are going through R1? I know 2 things. I can answer the question. What's V1 going to be? V1 is going to be 0.3333 times, what was the resistance? 20? It's going to be answer button times 20, and it looks like I'm losing 6.67 volts. 2 marks for that. I would give you 1 mark for that, 1 mark for the answer. What was the question there I heard? What's Okay, that would be another follow-up would be instead of the voltage drop, find the power usage, which would either be I squared R, it would be, or V times I, now that I know V. Okay, next page. Oh, now we're going to find the power usage. And here they didn't give me any hints, and that's probably what I'm going to do on the test. Here in number 2, I kind of walked you through it by giving you some hints. Find the total resistance. Now find the total current. Now you can find what you need to. On the test, I'm just going to say find something, and you'll have to realize all the steps that I've showed you. Step 1, label downhill. Step 2, try and find total current. I don't see amps anywhere. Step 3, look for 2 things. I don't see 2 things anywhere. Step 4, can I ski? Well, if I ski this ski run, I mean, I know the voltage in the 7 and the 16 and the 1 will add to 15 volts, but I don't know what each of them is. And same with that outer ski run, so that's not going to help at all. I'm going to have to rewrite this. So the first thing I'm going to do is I'm going to combine the parallel resistors. 1 over R parallel is going to be 1 over 16 plus 1 over 25. 16 reciprocal plus 25 reciprocal equals reciprocal. And I get, well, you know what? There's a 0 there. I'll go 9.7561 ohms. Now I want to find our total. Well, that's going to be 7 plus 9.7561 plus 1. It's going to be 7 plus 9.7. Well, wait a minute, Mr. Dueck. Use your answer button. Plus 1. 17.7561 ohms. Now, you'll notice, Daniel, I haven't actually redrawn the circuit. I might yet, but right now, I'm hoping if I can get I total, I might be able to get away without completely redrawing the circuit. But if I have to, I will. Oh, now that I know R total, what should I try and find next? Well, I know V total. I'm pretty sure it's 15. I total. I total is going to be V total over R total. It's going to be 15 divided by my answer button from 17.756. 15 divided by answer button, and I get 0.84478. Soon as I get that, I go label it on my main circuit. So, oh, how many amps are flowing through this 1 ohm resistor? 0.8478 amps. How many amps are flowing through the 7 ohm resistor? 0.84478 amps. How many amps are flowing through the 16 or the 25? Don't know. But now, for both the 7 ohm and the 1 ohm, I know 2 things. I can tell you the voltage. If I go that times 7, apparently it's 5.9135 volts. And here I can do 0.84748 times 1 in my head. It's 0.84748 volts that I lose going through that resistor. And now I can ski, because now if I ski this path here, it's going to be starting with 15 minus 5.9135 and also minus 0.84478 volts from the 1 ohm resistor. How many volts are left over? 8.2418. V equals 8.2418 volts. And by the way, there would also be 8.2418 volts lost in the 25 ohm resistor. What do they want me to find? Power. You know what? I'm technically done now, because now I could go power equals V squared over R. Cole, I just lifted that right from my formula sheet. You could find I, but I'm lazy. If I don't need to find something, if I can go to the answer from here, I will. So it's going to be, what was the voltage, Mr. Dueck? 8.2418. Don't forget the squared, divided by 16. It's going to be this number, don't forget the squared, divided by 16. Final answer, I would take probably 4.24 or 4.25 because there's some rounding off. In fact, really, I'd take 4.2 whatever. But I'll go 4.25. Power is measured in watt. If I saw that and I saw some work, I would give you 7 out of 7. Otherwise, I would give you 1 mark for finding R parallel, 1 mark for finding R total, 1 mark for finding I total. That's 3. I would give you 1 mark if I saw that voltage. That's 4. 1 mark if I saw that voltage. That's 5. 1 mark if I saw that voltage. That's 6. And then 1 mark for finding power, however you chose to find power. That's 7. Can you give yourself a clear score, please, out of... Is that the last question? Or no, there's one more. One more. Part B. Oh. Suppose the 25 ohm resistor is removed from the circuit. Okay. So, if we remove a resistor in parallel, what happens to the total resistance? Go up or go down? Okay, total resistance, strangely, even though you're removing a resistor in parallel, it increases. So what happens to total current? Decreases. And you know what? I think total current is going through that 7 ohms. So I think the answer is decrease. Now, if you want the actual numbers, I can crunch them really, really quick. If I remove that 25 ohm, then our total goes, I can do that in my head, 1 plus 7 plus 16. It decreases, sorry, it increases to 24 ohms as opposed to 17.7561. And then I total would decrease. It would be 15 divided by 24 to 0.625 amps. So if you solved it and I saw those numbers, I would also give you full credit. And 0.625 amps is less than 0.84478 amps. Okay. Oh, for the 2 marks, I would give you 1 mark if I saw that you had mentioned that our total increases or was 24.